So in this video we're going to discuss histograms, and in the previous video we went over the descriptive statistics output, and we're going to go through it again real quick just to kind of bring you up to speed. Maybe this is a new day, maybe there's a couple new things that'll be said, but I'm going to go fairly quickly through this portion of the descriptive statistics table so that we can get to the histogram portion, and then we'll kind of compare the histogram to the statistics. Okay, so just to repeat from a previous video, we're going to look at column 1, which is right here, and we're going to go to the data tab, go to data analysis, our descriptive statistics, select OK. I'm going to tell it I want to look at column 1 and highlight that. Visually, I'm expecting an n equals 51. I'm going to have it analyze one column instead of 51 rows, and the label is in the first row, so I know that I could change that to be very helpful if I was moving it to a report or document that someone else is going to read. I want to put this here in our main page, and I definitely want the summary statistics to be displayed. I'm not interested at this point in these other items. By selecting OK, it generates a report. I'm just going to size this accordingly so I can see what's going on. Now, we recall from our previous discussion that this part here is our X bar, or arithmetic mean or average. The median or middle value right here is it would be 4 if I put them in a line, or I put them in order. The mode is 4. This occurs the most out of anything, and we would expect the mean, if it was normally distributed, to be somewhere around this number. The standard deviation, right? We'll say x sub I because this will come into play later. And then the sample variance we typically don't use in normal conversation because the units are a little funny, so we square root it to get the standard deviation. Kurtosis is a measure of how pointy the distribution is going to be. It's actually technically a definition of whether it's light-tailed or heavy-tailed. We'll cover that throughout the next several discussions. Skewness is whether the tail goes to more prominently to the left, which would be negative, more prominently to the right, which would be positive. The range is from the maximum to the minimum, so we have 5 different values here, 1, 2, 3, 4, 5, 6. The sum if we added them up, and then this is our n value. Okay. Now we want to discuss histograms, and histograms are going to come into play quite a bit in helping us understand what's going on with the data set, and eventually help us understand how to utilize it, or if we need to abandon what's currently there and take a different approach. So going back to our data tab, we're going to select data analysis, and in this time we're going to select histogram. So go ahead and if you can't find it directly, just kind of move around, and this is where it is. Histogram, OK. And we see another dialog box. So we're going to go through this and recognize that there's a logical sequence, and if we can use it, we will. If we need to make some changes, we'll make some changes. So input range, we're going to use the same input range as before, column number 1. May sound a little redundant, but make sure that your input ranges are the same. It's when you're moving fast, sometimes it's easy to forget where you're at, and Just double check that. Now, bin range. What is a bin range? We haven't really discussed this, and I think it might be missing from our page. So let's discuss it and kind of figure out what's going on. Now, the bin range is this. Everything with a 0 should be counted up. Everything with a 1 should be counted up. A 2, 3, 4, 5, 6, 7, etc. We don't have bin range established. So let's kind of go back, cancel this out, and let's establish our bin ranges. So simply type in there bin range. Now, how do we select a bin range? It's always a challenging question, and when we get to the live data set, there are so many different ways to approach it. So in this case, we can mimic what's been given to us, 0 through 7, right? Or we could look at our maximum and minimum and divide it up into the number of columns we'd like to see. So, you know, this has 8 columns. Maybe we want to see that. We could divide, well, it'd be difficult to divide it into 5 or to 8, but we could still do it, right? So let's just kind of mimic our what's provided for us. We know our range is from 0 to 7 if we were to use everything, or if you wanted, you could use 1 to 6. But in this case, we're going to use 0, 1, 2, 3, 4, 5, 6, 7. So this is our bin range. All right, I think we're good on this part. Let's go back through our histogram process and make sure that everything matches up in that. So back to data analysis, so the data ribbon, data analysis, histogram. Of course, if you already had this selected by default, it should be still there, and we'll select OK. Our input range, we're going to double check, we're going to verify we're still using the same column number 1. Right? We expect there to be n equals 51. Now we have our bin ranges, which is great. So select bin range, and be sure to select that it has a header, like a title, so otherwise you'll miss that 0. Right? And we want to make sure that we let them know, hey, it has titles there, so let's exclude that so we're not getting the computer confused. Our output options, this looks very similar to what we had done before. So output range, I'm going to just put it right here on our screen, right up here, so we can kind of work with that side by side. Now, please be careful with this. It's very tempting to use something creative like the sorted histogram. The sorted histogram takes the bins and arranges them from the largest to the smallest. So when you're considering normal distribution, this is a little counterproductive. It just always looks like it's heavily skewed. You'd have to look at the titles at the bottom or the labels at the bottom. Cumulative percentages can be fun. It creates this kind of S curve or some sort of curve that says, oh, okay, we're reaching 100%, so it just adds it up. I've found that for most of what we're going to do in this course, that's more of a distraction than a help, but you're welcome to play with it. And then chart output, which is the actual histogram. So if we don't select this, we're going to get a small table that says, you know, what the bins are, but we won't get that graphic. So we really want that graphic. So select chart output and OK. It's going to think for a bit, and there we go. Now, officially, this is what we have, right? So this is our bin range. 0, there are 0 zeros. There are 4 ones. There are 2 nines, 9 twos, 11 threes, 16 fours. Interestingly enough, we see this is our mode, right? Our mode where this shows up the most frequent. And then it kind of comes back down, and it mimics this chart mimics this histogram, or this histogram mimics this chart right here. All right, I'm going to do a little bit of cleanup here. You could just select this title. There's only one item, and we'll move over here. We'll cover our frequency because we don't really need it. It's more important to kind of discuss certain pieces here. All right. So let's look at our average, our X bar. Right, we're gonna go here. We're gonna insert some lines. You don't have to do this on your side. This is really just for us to have a discussion. So I'm gonna draw a nice line here, and I'm gonna make it a little bit bigger. So we look at 3.4 is our, so if this is, right here is 3, then this is 3.5. So we'll kind of put our high point here. In this point, the standard error is not necessarily something we need to discuss at this point. We know that the mode is right here. We expect that to be the tallest point, even though the average is right here. This is the tallest point. We do have a standard deviation, right? So standard deviation would work where if we take the mean, right? Let's just kind of simplify this, and we'll say that the mean is 3.4. Right, so we just said 3.4, right? And the standard deviation was 1.27. 1.27, right? So if we added these together, right, oh, I'm sorry, let's make this 1.3. Just kind of keep it simple. So if we added these together, we would get 4.7. Oops. Right. So 4.7 would be one standard deviation. Right around. This is 5. This would be half. So there's 4.7-ish. Well, what if we subtracted that? Right? What if we went the other way to the left? Right, we would be at 2.1. Right. So here's 2, and say there's 2.1. So that's one standard deviation, plus or minus, right? So let's kind of start marking up our histogram here. Right, so we have, this is X bar. This is standard deviation 1. This is standard deviation minus 1. Right? Let's pause for a moment, and why don't you see if you can calculate standard deviation 2. Right. At this point, hopefully, maybe you're able to predict certain things on how this is going to turn out just by kind of playing with the data. Let's go ahead and set 2 standard deviations, and we'll say, kind of write a formula so you can all see what's going on, equals this, which is our X bar plus 2 times our standard deviation, and that puts us at 6. So 2 standard deviations is at 6. Now if we take our formula and then just do minus, you end up with 0.8. There's 1, there's 0.75, so maybe 0.8. All right, so we'll go ahead and write in our -2 and +2. Alright, so here's what's happening is we're capturing the descriptive statistics quantitative portion and really understanding what it means in the histogram. So if we shorten these bars to where the histogram is, this one's going to be a little trickier. Kind of pick a place that we feel it might be represented in here. So these are intermediate or representative of our normal distributions. And if we actually draw a line, right, we end up with kind of this. Right. Let's try that one more time. And this would be our normal distribution, really modeling it out on the histogram, what's happening. All right, so let's move this out of the way here. We'll kind of keep it. It's not the greatest art, but it is a reasonable representation. We're looking for a normal distribution. Normal is not as in typical, but as in this nice bell curve. How evenly distributed is it? And again, we're using a fairly manufactured data set, but we get kind of an idea that there's a nice rounded feature to it, except maybe like one of the tails doesn't exist a whole lot. It's not, you know, this part here is a little smoother here, but this kind of gets cut off, right? And we see that in our kurtosis. But also, this is a little less self-evident, but we see, let's get rid of this here. We see the skewness value here is that it is slightly skewed towards this piece. So if we're actually carrying it out, this tail here is kind of pinched and pulled out. So we're actually kind of compressing this portion over this part here, right? Let's see if we can get rid of those items there. All right. So this is our normal distribution, and it looks fairly reasonable as what we would expect. Maybe try this exercise with another column, whichever column you wish. Remember, columns 1, 2, and 3 have an n value of 51, which we see right here. 4 through 10 are n values of 50. Maybe give it a try with another column. Change the name so that you see a new title up here. And maybe try to understand what's happening with each piece. And we'll go through a quick quiz next. They'll use this exact data set, so if you're comfortable with all columns, and once you get comfortable, running the stats is really quick. You could do it in just a minute or maybe two. So for a couple minutes of learning or remembering how to understand it, we'll give you this real quick series of checking everything off.